course, I forgot to hit record despite the reminders, so for the purpose of recording, we're taking 5 to 7 minutes to work out these problems.
I have a question.
Yes.
For the second one, the one that's like number 9, is it an x plus 8 or an x plus 9?
It is an A, thank you.
Okay, thank you.
Betrayed by handwriting. go ahead and raise your hand when you're completed online. We're at about the 5-minute mark. We'll take a couple more minutes to get caught up. And this one is for later. I just didn't feel like writing it out while you were waiting on me. All right, that's about 7 minutes. So, in the interest of learning pacing, there are 60 questions on the math section of the ACT, and there are 60 problems. And so it's not a very hard math problem. You need to be averaging about 1 question per minute. Now, when we have them at the very beginning, for instance, this was a problem 9 on a test, this was a problem 9 on a different test, this was a problem 3 on a different test, especially those at the beginning, you should be able to whip out really quite fast so that when you get to the middle test problems, you have that extra time to work on them. And so that's what I was going for with this set. Both it's a review of the quadratic stuff, but also to just help you get familiar with that pacing. Ideally, we would be able to do these in 6 minutes. I said 7 for a little bit of a buffer. So the first 3, starting in the very middle, this is the concept of what a solution or a zero or a root is for a quadratic. What would our answers be? So what would our solutions be for that middle number?
It'd be ax plus bx.
No. Okay, so this is why we go back. The idea is if this equals 0, then either this piece equals 0 or this piece equals 0. So what value of x would make that equal to 0? It would be the opposite. So you can write it out if you want to and say x plus a equals 0, subtract a from both sides, x equals negative a. And for this one, x equals negative b. Same thing's going on with this one, except now we have numbers. So 2x plus 5 equals 0. Subtract 5 from both sides. 2x equals negative 5. X equals negative 5/2. So those are what the solutions or zeros or roots are for quadratics. Same thing here, we'd end up adding 4 to both sides, so 3x equals 4, x equals 4/3. Questions on that? Is it something that, oh yeah, I remember that now that you talk about it? Okay. For number 3, how did you solve that? What do you do?
-4.
Okay, minus 4. So x squared equals 24. minus 5. Plug in x, okay? So whether it's plus or minus, we square it, we're going to go back to 25. And then 25 minus 4, 21. This one's not necessary. Again, you guys are so used to being hard that you're trying to make it too hard. If x squared plus 4 equals 29, then x squared equals 25, you can just subtract 4 from both sides. You've got an x squared, you still need an x squared at the end. You don't have to do the square root. You're just trying to figure out, okay, if x squared plus 4 equals 29, x squared minus 4 is going to equal 21. All right. So, 39. I picked this one because a lot of people are comfortable when it's up here with the x terms and the numbers on multiplying it out. But I chose this one because even when there's variables, it's still going to be the same process. And so whether you are a distributive all the way type person, whether you like the box method or you go back to FOIL, either way, it's the same method of multiplying this out. And so knowing what you are comfortable with, go for that thing. I would probably do FOIL just because that's the one that's most ingrained into my brain. If I were teaching it to somebody who is not confident about it, I would do what I call the box method. And so that's the one I'm going to demonstrate. If your brain doesn't say, oh yeah, I remember what FOIL is, then this can help you. Remember, if we're multiplying, that is one length by another length. One of these lengths is a plus the square root of b. Another one of the lengths is a and then minus 2 square roots of b. I apologize, my handwriting's getting a little crowded. And so we have a times a is a squared. A times positive square root of b is just a square root of b. A times negative 2 square roots of b is negative 2a square roots of b. And positive square root of b times negative 2 square root of b is going to be negative 2b. A squared is just a squared. We have positive a square root of b and negative 2 a square roots of b, so we have negative 1 a square root of b, and then the minus 2b hangs out at the end. And so again, if you don't remember how to do FOIL with first, outside, inside, last, that one is a really good way to organize your thoughts. Questions on that? I feel like I'm doing a lot of hand waving. Hopefully this is familiar. Okay, so the last one gets more into, well, it's not the last one, but this one over here. This gets more into the end of Algebra 2, when you were dealing with rational functions and you'd have things on the top and the bottom that you needed to cancel. For this, I am fond of saying, use the information they gave you. Because of the setup and because they ask you to simplify, you know that something's going to cancel out. And so here, they give us x plus 1. I know that this is going to factor into something with x plus 1 in it. I just have to figure out what the other piece is. And so here I've got 7. 7 times 1 would equal 7, so this is a 7. And it's positive, so it's going to be x plus 7 is that other piece. The same way, we've got a minus 3. I know I'm going to end up with x minus 3 down here. I just have to figure out what the other piece is. So negative 3, negative 21, this is going to be also plus 7. So x plus 7. And so when they give you those simplification things, you don't even have to factor it cold. They've already given you a hint of what is going to be in there that's going to get canceled out. And so x plus 7 cancels. X minus 3 cancels. X plus 1 cancels. And we have just plain 1. So with this one, when they asked for exact roots, this was labeled as a challenge problem. It's not truly a challenge as in being difficult, but it does take up some time because there's no shortcut on this one. Because they asked for exact roots in simplest forms, you can't just run it through your graphing calculator and take a look at it. You're gonna have to either complete the square or run the quadratic formula. So, question for you is, which one of those can you do? Which one of those are you comfortable with? Because if you can't do either of those, I'd be looking at graphing it and then getting decimal approximations of the options they gave me. It's kind of an ad hoc method, but it'll work in a pinch. But we have, and I'm gonna erase this one so I've got more space. So we have negative b plus or minus the square root b squared minus 4ac all over 2a. So, if possible, still have this memorized. And we'll talk about this answer first, and then we're going to talk about it more in general. So, A, B, and C are talking about the coefficients in a quadratic equation. And so we have negative 8 plus or minus the square root of 8 squared minus 4 times a is just 1, we can leave it alone, times negative 3, and so I'm going to take it 3 and change the sign there, and then all over 2, again a is just 1, we can leave it as 2. And that's what you would have to simplify. So, talking about the quadratic as a general rule, I take a lot of ACT tests both to hunt for problems and to keep fresh on the type of questions they're asking, but also your brain starts noticing trends. Your brain starts noticing these are the types of problems you see a lot. Wow, that's a weird one. I haven't seen that one before. And so we try to give you samples of anything possible you might see, but we really focus on what shows up over and over again. So this one's kind of a one-off problem. I don't see a whole lot of problems that need the quadratic formula and only the quadratic formula in order to get the right answer. But what you do see is within this formula, there are 3 useful pieces. One is the whole thing. And that gives roots. Roots, zeros, solutions, x-intercepts, all the same thing with different names. But this negative b over 2a, do you know what that gives you? This plus or minus is the key. Negative b over 2a is that axis of symmetry. Everything is going to be mirror image on both sides of this piece. And so negative b over 2a is the axis of symmetry. Or the middle. And if you happen to be looking for a max or a min, that's your x-coordinate for the max or min. And so you can shortcut, and again, if you've got the whole thing memorized, know that that front piece is the middle that you're looking for. The final piece is this part, under the root. And this can't write. It's called the discriminant. Or in other words, the piece that helps us tell the difference between the types of equations. If you have a square root of a positive number, great, it's a positive number. It has two real solutions. If you have the square root of 0, plus 0 or minus 0 doesn't change. That is one real solution. Or in other words, the vertex is sitting right on that x-axis. And if it's negative, square root of negative, imaginary. No real solutions. And so our three options, if it's positive, our graph looks something like this, where it crosses in two real solutions. If it's 0, our graph looks something like this, where it only touches and has one real solution. And if it's negative, that's when we have those imaginary, no real solutions. It doesn't cross that x-axis. And so there's no true answer. If you look at page 8 in this booklet, it's got that written out in more detail. So you'll notice the middle of the page has the discriminant, and then the next thing below that talks about the axis of symmetry. Things that I would add to this if you need it at all. If a graph has a max, then the graph has that negative coefficient. I apologize for my handwriting. And it's going to be frowning. That's the best that graph can get before it turns back and goes down. If a graph has a min, it has a positive coefficient, and it smiles. That's the lowest it goes before it turns around and goes back up. So that one's just a memory thing for me. Understand that the maximum, that's the highest it gets. Minimum, that's the lowest it goes. All right, took a bit of a detour on that. Talked about quadratic. Okay. I'm going kind of fast because we are going to run out of time very quickly, but I want to slow down. Is there anything that we've done so far that you'd like another example of or more clarification on, both online or in person? Anything that I can add? So this one is a very wordy, semi-real world problem. And so it tells us that the breaking distance, y feet, is modeled by y equals 3 times x squared plus 10x all over 40, where x is the speed in miles per hour. And according to this model, what would be the maximum speed in miles per hour Damien can be driving so that the braking distance is less than or equal to 150 feet? So the very first thing that I would remove as a distraction is the idea of less than or equal to. Because they asked us for the max. And if they asked us for the max, we don't have to worry about the less than. We're just dealing with equal to. And so we have the idea that 150 equals 3x squared plus 10x all over 40. And our options are 10, 30, 40, 50, and 60. My question to you is, how would you tackle this problem? There are no right answers, but again, your common enemy when you are taking the ACT is time. You want to get an answer in as little time as possible in order to save that time for the next question. Technically, you could run it through the quadratic equation, but it's not in nice, pretty ax squared plus bx plus c form. And so it would get ugly really quick. The two methods that I would use to tackle this problem is either graphing calculator or guess and check. If you're comfortable with a graphing calculator, I would subtract the 150 over so that you're looking specifically for zeros, and then I would be looking at the graph from there. But let's pretend you don't want to do the calculator. I want to talk about the strategy of guess and check. How would you guess and check these numbers? Where would you start?
The middle number.
The middle number, because depending on what answer you get for the middle number, you either have to check this way or this way. It cuts the repetitions in half. And so you would plug in 40 and see, does this work? And in that case, you probably want to go back to our inequality because it says that the braking distance is less than or equal to 150 feet. So we want to satisfy that inequality that it's less than or equal to the 150 feet. Again, if you were trying to do this by solving, you'd treat it as the equality problem. If you are doing guess and check, the inequality works. So, does 40 work? Does. So, what do we check next? Next one down. If 40 works, we're trying to check, can we go faster? Does it still work at 50 miles per hour? Beauty of calculators, you can use that editing. All you have to do is change the number. And you don't even have to change that much. All you have to do is change the 4 to a 5. The zeros can stay. Does 50 work? I think that was a head shake, no? All right, so we would stay at 40. So when you get to problems like this, sometimes plugging it in and checking is the best answer and best solution. The test does not hold that against you. It's showing that you understand the concepts. All right. We've got about 10 minutes left. So, lots of words again. I'm going to read it off and then write the most relevant ones on the board because if I try and copy it down, we'll be here all day. So, projectiles launched from a cannon on top of a building. No points for art, but it does help with the reference. So we have a cannon on top of a building and a projectile is launched. The height of the projectile in feet can be modeled using the quadratic equation that height equals negative 16 t squared plus 128 t plus 320. Where h represents the height and t represents the number of seconds after the projectile was launched. After it is launched, how long will it take the projectile to hit the ground? So, we have t seconds, we have height. How long will it take to hit the ground? And the options are 2, 4, 8, 10, and 12. If you are comfortable with the graphing calculator at all, I would encourage this one as a graphing calculator problem. All right, what have you got? 10? Agreements, disagreements on 10? So, I'm going to speak about it because I have both lived through it and witnessed it happen. So, I took the ACT 3 times, once in 8th grade, once in 11th, once in 12th. When I took it the last time, I was trying to improve my score from my junior year. I had gotten a 32 and I was curious if I could do better. And I did better on the English part, which was the one that I had been practicing for. I did worse on the math because I forgot my calculator at home. Do better than me, don't forget your calculator. So I did it without the calculator and I got a 32 again because my English went up and my math went down. So, if you were trying to tackle this without a calculator, I would be dividing everything by 16 first and then dealing with smaller numbers. So if you were tackling it that way, just so you know, other than that, graphing is great. Putting in and testing numbers and seeing which one gets you close to 0, also good. All right. Branching out a little bit from the straight solving, these ones are ones that are interesting but less common. So I have a graph and it comes from above, it swoops down, touches at the origin, swoops down again, does an inflection point, and goes up. So, again, this is at 0. This is at 6. And this is at -4. The question is, what is the lowest possible degree equation that could create this graph? What would the function need to have? And so, would x squared be enough? What would all the pieces that you need in order to create this function? That face looks a little lost. Have I lost you? Okay. I'll give you 1 minute and then we will go over it. All right. So, the first thing that we need to remember is that every zero of a function is also a factor of that function. And so what I mean is, if this 0 is at -4, one of the factors for our equation is going to be x plus 4, because -4 is what makes that factor 0. What's going on here at the origin? So when it touches but doesn't cross, this is a double root. It is just plain x, because if x were 0, that would create a 0. But because it doesn't cross, it is an even power, and the lowest possible is just x squared. And then finally, our last 0 is at x minus 6, because 6 makes a 0. But it's not a nice, pretty, just crossing the way this one was. In order to have it do that flatten, that would be a third degree function. And so this is x minus 6 to the third power. And so being familiar with what those individual pieces do is the key to this problem. This problem is not as common as some of the other ones. I've seen it a couple different times, but not necessarily every test. But understanding what these factors do in the equation is a good thing to know. All right. I will leave it up to whoever is most vocal. Easy question or hard question to finish off on? We've got about 3 minutes, so. I didn't hear that.
Let's go easy.
Okay, go easy is the local one I heard. So we have x squared minus x minus 30. And they, common technique in the ACT, rather than asking you what are the solutions, because that would allow you to plug things in and try them, They instead ask for the sum of the two solutions. And so it kind of buries them within that question. And so it's a leading coefficient of 1, which is kind of friendly, but you have to be able to find the zeros of this equation. Again, quadratic formula always works. It's a little bit of a too big a hammer. It'll take you too long. You're welcome to use graphing. You're welcome to use factoring. Just find the answer whichever way you feel comfortable. Time, so I'll do it quick. The X factor of organization is not required, but I like it because it helps keep my thoughts organized. We are looking for two numbers that multiply to -30, but they have to add up to -1 or have a difference of 1. In order to multiply to -30, we're looking at a positive and a negative number. And in other words, they're 1 apart. So what are two factors of 30 that are 1 apart?
5 and -6.
Good. So you're correct. The negative gets the 6 because it's the bigger number in order to combine to a negative number. And so our factors are x plus 5 and x minus 6. What are our two solutions?
X minus 5. X equals -5 and x equals 6.
We have -5 and positive 6, and if we add them together, we get positive 1. One of the false answers that they will give you, and it will drive you crazy because you will know it's right, but then because you're trying to hurry, you'll mess it up. They will also offer up -1. And so if you stopped here and just added those together, you would be getting the -1 rather than adding up the solutions to get the positive 1. So be careful not to jump to, okay, I have this is the answer. Still get that opposite sign whether you write it out or not. All right, and with that, we are done for the day. So, you know the drill on packing things up? Have you done the putting the chairs away and stuff? Okay. Yep. Especially as you go on and are doing homework type stuff, you are always welcome to bring questions. So, as you practice, do find them.